my name is John Arthorn. I've been working on Eclipse for forever, essentially, since before it was called Eclipse, in many different roles. And most recently, I've been working on the Orion project, which is building browser-based development tools. But today, I'm going to be talking about continuous delivery in general, and about the kind of development tools that people are finding that they need for doing continuous delivery, and some of the work we've been doing in that area. And even though it's a sponsored talk, I promise this is not a sales pitch. It's a technical talk. I'm going to be talking about material that I think is really interesting for all of you. There'll be some mentions of IBM products, but that's not really my focus here. So I'm going to be first. I'll introduce the topic of continuous delivery, just to make sure we're all on the same playing field to understand what I'm talking about when I use that term. Then I'm going to talk a little bit about the tooling landscape around doing continuous delivery and DevOps today. And then I'm going to talk about some of the challenges that we're seeing in that area and some ideas that our team has on how we could help do a better job there and provide better tools. So just to give a little bit of context of what my team works on, I kind of have two hats. I work on the open source side of Orion development tools, but also a team that consumes that within IBM for tooling for Bluemix, which is IBM's cloud platform. So I work on a fairly small agile development team, but within an organization of a few hundred developers who are working on Bluemix in general. So that's just a little bit of context of where I'm coming from. And the material here is really both based on our team's experiences and moving towards our own, the Orion IDE, moving it into a continuous delivery model, but also helping customers and users on Bluemix who are also kind of faced with the same kind of challenges and helping them out. So that's where some of these experiences come from. So, the position we find ourselves in when we're working in the cloud development space is that we're constantly under pressure to move faster. And there's two major areas or reasons why we're under this pressure. So number one is there's this business pressure to move faster, and a lot of that comes from changed expectations on the behalf of consumers of technology. So you can blame it on the iPad or the mobile app revolution, but end users of technology today expect a very different experience when they're working with when they're dealing with technology. They don't want to see these giant monolithic applications that take years to build, and then when you make them available, they're super powerful and complex and hard to use. What people are expecting today of technology is for it to be extremely rapidly available. So they want to have that app available, immediately when there's a need for it. They want it to be very small, very focused in solving a particular problem and doing a really good job at it. So that agility, that ability to move fast, is really important when you're building apps, for running on the web and also for mobile and cloud. The other major pressure is on the technology side. So when you're building an app that runs on servers and runs in browsers, you have to be able to move fast as all the technology around you that you rely on. So the most obvious one is every 6 weeks a new version of Chrome comes out. That could totally break your app. So you have to be ready to deploy a new version of your app on a moment's notice when Chrome comes out and breaks you. And that has happened to us a number of times. If you're building really interesting, complex web applications, new browser versions can easily cause problems for your app, and you have to be able to respond quickly. Even more quickly than that is when you have security problems. So you have so-called zero-day security exploits where, as a cloud provider, we get advance notice before the release to the public, and we have 1 day to prepare and release a fix, which could be anywhere within in our technology stack. So you have to be able to respond to those technology pressures and be able to move any piece of your technology, whether it's your servers, your middleware, your application, your web front end. You got to be able to deliver changes to that really quickly to be able to respond to that kind of challenge. So how do we get there? How do we move faster? So I love this quote from Thomas Watson, who's one of the early presidents of IBM, like back before computers were invented. But he had this saying that if you want to, you can't control your success rate, but if you want to increase it, the best way to do it is by increasing your failure rate. And what he means is you just have to move faster, try things faster, move at that faster rate. And yes, you will fail along the way, but that's the only way that you can increase your success rate, is by pushing the boundary and forcing yourself to move more quickly. And that's what our team has been trying to do, and we've been dealing with the challenges related to that. So, this brings us to this concept that is, very popular today of doing continuous delivery. And just to give you a basic definition of the term, you probably all heard of continuous integration, and I'm sure most of you, if you're developers, you're practicing that today. So you're probably using, Jenkins or Travis or Hudson, and you've got a build that's running out there somewhere that's doing continuous compiles and continuous unit tests against your application. Continuous delivery is really about taking that continuous cycle of CI and pushing it all the way through to production, so that every time you make a change, or at least every day, you not only push it to a build farm, run your unit test, but you also push it to production in the end. And there's many steps along the way that you need to do that reliably. But it is about reducing the time from commit or code change to in your customer's hands. And the companies that do this really well today, you're talking about 10, 20 minutes that they can do a turnaround. So, some of the really top-notch cloud companies can deliver to production 20, 30 times a day, and they can turn around a change within 20 minutes if they need to. So that's the kind of speed that is actually possible when you kind of adopt these new set of practices around it. So I'm actually not, I'd given a talk at Eclipse Conference that was all about those practices and processes around continuous delivery. I'm actually not going to talk too much about that today. I'm going to focus more about different tooling. But just, there's this resource out there that we've put together recently. So if you go to ibm.com DevOps method, this is a site that we put together. My team worked on it and others worked on it, which is, all the content on there is written by developers, and it is information about DevOps and continuous delivery and the practices and the processes and things that you need to be successful at that. I think it's actually a pretty good resource. Like, it's not a marketing site. It's really built for developers. And one thing I really love about it is that they've not, as technologists, we always like to think that there's a technology solution to every problem. And the resources here really acknowledge that it's not just a technology problem, and if we throw enough technology at it, we'll solve it. You notice that culture is right in the middle there, and there's some ideas on the site about, how can you adopt your team culture to be able to work in a continuous delivery environment, which has very different pressures on it. So I'd encourage you to check it out if you want to do more background reading. Okay, so now I'm going to shift and talk about the tooling landscape for teams that are practicing continuous delivery. So, what many of us came from and many developers are still in today is what I call a closed world development model, where everything you need to do from writing the code to releasing it to a customer, you can do from your desktop. So this pretty picture here is from the Eclipse 1.0 architecture diagram, showing how it can bring all your development tools together so that your IDE or your desktop can be the integration point for every piece of tooling you need in order to build and deliver your application. And that worked out really well when what we were building was desktop apps, right? So if you're building an app that runs on the desktop, then you can actually, you have an environment locally which is like your production environment, that your customer environment, and you can run your app there and you can debug, directly against it. And you've got this really perfect environment where you can do that whole end-to-end app development lifecycle entirely from your desktop, from your IDE. So that was a really fantastic world to work in. And if you're still doing desktop application development, you're probably still doing that, and that's great. That's nothing to say that this isn't a good model. This is a great model for doing that kind of development. But it's not the reality when you're building for the cloud and building for server environments. So there's two major categories of reasons where this kind of application development model fails and falls down when you're building apps for the cloud and when you're trying to practice continuous delivery. So the first, fairly obvious one, I think, is that your production environment, your runtime environment that your customer is using your product in, is not a closed world, right? The internet is a chaotic environment. You can never emulate that production real-world environment on your desktop. Unpredictable things happen, traffic flows change, the technology around you can change. It's an environment that you can just never perfectly describe in your local world and test against it and be confident that once you've tested it locally, you can push it over to the customer and it'll just work. You just can't rely on it. And the other reason I think is a bit more subtle, which is that when you were working in that model where you're releasing, say, once a year, you know, we all know that releases are a scary thing, right, as developers. Releases is when, you know, that's the main source of stress as a development team, right, is that getting over that hump and delivering. You know, that's where a product the success or failure of a product can ride on how that release goes. And we've developed this whole set of culture and practices about how to do that in a way that we end up with something after a year or 2 years that is reliable. And you know, a lot of you are probably familiar with the way the Eclipse community works and how they have an annual release train, and they have a very predictable model where they do things like front load the risk. You know, you put the big scary changes in early, you give it a lot of soak time, you have a very carefully orchestrated ramp down where you reduce the amount of change going in, and that helps mitigate the risk of delivery, right? So you can afford this really long cycle where you do that ramp down and have all those practices. But if you want to release to production 20 minutes after you wrote your code, you just can't afford that kind of methodology, that kind of practices. You need to be able to, you need new tooling to actually help you gain confidence really quickly that the change you made is good. And the kind of tools you need to do that need to be running out there where your app is running. They can't be running locally. And if I have time, actually, I'll show some more detailed examples of tools that I'm thinking of. So what we end up with, the tooling landscape we end up dealing with when we're practicing continuous delivery and when we're working in the cloud world, is that we have our set of development tools is essentially kind of exploded out from the, like in this diagram on the left, we've got some of these, you know, design and coding tasks you can still do on your desktop. But a lot of the other tooling capabilities that used to be able to run locally are now kind of exploded out, and they're moved more towards where the runtime is. So you think about your development environment is kind of on the far left and your runtime world is on the far right. A lot of the tools that you need to be successful here have to be running out there where your app is running. So, and there's kind of a big cluster around testing. You need this test environment that is like a production environment where you'll be able to run, you know, not just unit tests, but, you know, Selenium tests that do, you know, drive your actual UI, you know, blaze meter tests that do load testing. You need to be able to do all these different kind of tests that you can't do locally. Like you cannot simulate 1 million users in a local environment. You need to have a very different kind of environment to do that. You need your tools to be working in that kind of environment. And then you have another cluster of tools that actually are integrated directly into the runtime environment. So you need to have very tight monitoring of your application. So you have tools like Uptime and Pingdom that let you know when your site is suffering. Tools like New Relic that let you do really deep introspection of how your runtime application is really running. Tools like Google Analytics, I'm sure you're all familiar with, for gathering measurement of behavior on your application. So all these tools have to be living in the production application world, not in your desktop world. So, you know, just a little sidebar, since this is EclipseCon, I wanted to, you know, throw in here, where does that leave the IDE, right? So in the past, the IDE could be the place where every single tool came together. The reality today, I think, is that the IDE can no longer be that one-stop shop that integrates everything. But that's fine. You know, if I'm doing Java development, there's no other place I'd rather be than in Eclipse, right? Like, it's a very powerful tool for that core coding experience. But I think what it's done is it's opened the door to other kinds of editors. So a lot of people are building in the cloud are using lighter weight editors like you know, Sublime or Quick Edit or you know, there's a whole brackets. You know, there's a whole series of different Atom as well. Like, there's a lot of these different lighter, more focused editors because they realize that they can't actually integrate all your tools, but they can do a really good job of the development time experience, the typing and the coding experience, and that's what they focus on. And I think actually Eric Gamma at Microsoft gave a really good description of this in a talk recently where he described it as a spectrum. So you have these very heavyweight, opinionated, strongly integrated tools on one end of the spectrum, and at the other end you have, like, you know, Notepad, you know, just like core, it's just editing characters. But there's a spectrum there in between, and I think IDEs like Eclipse can evolve more towards that lighter weight experience where they, you know, maybe they can't integrate every single tool in your tool chain, but they can still, you know, become more lightweight and really, you know, provide a really good development time experience. And there's also, of course, I should mention, like browser-based tools like a picture of Orion here that, you know, they can also fulfill that kind of core coding experience because they don't have to be able to integrate all these other tools. They just need to focus on doing a really good job at, being a good development environment and coding environment. Okay, so now I'm going to talk a bit about some of the challenges that we're facing when working with some of these new cloud-based tools. So the first one is a really big one, is the setup cost of these tools. So if you think it's painful to install a tool into Eclipse, you haven't heard nothing. Like the cost of installing these tools is very high. Like I've got some screenshots here. You probably can't really see it, but I have the table of contents for installing Hudson, which is 16 chapters. I have the table of contents for installing GitHub Enterprise, which is 30 chapters. And then I have a 37-page document for installing Elk, which is a log monitoring and analytics tool. So these are really complex tools to get set up. They're great tools, but they're really costly. They're a lot of work to get them going. And then the next thing you face is an integration cost. So you're dealing with, there's no single tool that solves all your problems. You have a lot of these different tools, like I showed in the chart earlier, where you have across test and monitoring and scale, you have these different kinds of tools that need to integrate with each other to do a good job. And that integration cost really kills you. So, I have a couple of screenshots. One is the guide on how to integrate Selenium with Jenkins, and that's a 13-page guide. And the guide to how to integrate HipChat with PagerDuty is a 12-page document. So that's, again, this is just, and those are just two examples. Like, let's say you're using 10 of these tools, and it's an n squared problem, right? Every one of these tools, if they want to integrate with each other, you have to configure those integrations, and it becomes really expensive, and you end up either spending a lot of the developer's time doing this thing, or you end up with a dedicated tool chain management team that's essentially working on configuring and maintaining these tools. That's actually what we have internally. We have a whole team whose focus is installing, integrating, and maintaining the set of tools we need to be able to do continuous delivery, and it's a big cost. The other kind of paradoxical cost is this, there's this notion of the paradox of choice. When you actually have, this is not a consolidated market. There are a large number of tools in this space, and they, a lot of them are really great point solutions to individual problems. But trying to decide which one to use is just bewildering. A lot of IBM customers that are new to this, they come along and they're like, what should we use? There's 6 different tools for monitoring and 8 for doing instant messaging, and 4 different CI engines. Which one do I pick, and how do I put which ones work well together? Figuring that out, figuring out which one to use is a big cost when you're dealing with these tools. And then again, if you make a bad choice, you're faced with that integration cost again of, I decided to switch from HipChat to Slack. I got to pull out all those integrations and insert a whole bunch of new ones. So you have a big cost there, the switching cost too. So just to summarize the problems we're facing when doing continuous delivery, it is really hard to package and deliver those tools to a developer or to a development team. You have significant cost in doing the setup and maintaining the integration of those tools. And you have this bewildering way of choices where teams end up spending a lot of their time just trying to figure out what tools they need to use to do their job properly. So the real capsule summary here is it's really hard to set up and instantiate these tool chains in a really scalable way, especially in a larger organization. You feel like you're spending a huge amount of your time dealing with these costs over and over again. So this is a problem that our team has been thinking about a bit. How do we provide integration between all these different tools, and how do we do a good job of removing some of that cost and getting you productive quickly and getting you developing your app much more quickly. So I'm actually going to show you a demo, hopefully if the network is okay. This is really early work. So this is, our team has been working on this in the past couple of months. It's really just a prototype of an idea that we have of how we can solve some of these problems. And we've taken this, for the past year, we've taken this approach of, let's not go off for 3 years and come up with something. We throw out ideas really quickly and see what sticks, see what resonates with people. So this is just a really early prototype that's available. If we get a lot of feedback that it's solving a good problem, interesting problem for people, then we're going to be putting a lot more work into it. And I think there's actually a really no, oh, I'm not actually showing anything right now. None of this is actually open source today, but I think there's actually a good opportunity for doing open source for this stuff, because it's really, it's about integrating tools. It's not about, the value out of the tools themselves. So, there's nothing out there today, but, okay, why am I not displaying? Let's try this. Okay. Okay, so here I am on GitHub. I see this application, this app looks really interesting. I want to start using it, start working with it. So it's a Node application, uses Express as the server engine, and it's just a very simple web application that I want to start building from on my team. So I look through it and I see that there's this button here that says, deploy this. So I'm going to say, sure, I'd like to deploy it. So I'm going to, and let's see how slow the network is here. I have backups, so this is terrible, and we'll switch. It's looking pretty slow. All right, too many people on their phones and laptops. So this is what you get to is a screen that says, okay, you're going to deploy this app. Give it a name, pick where you're going to deploy it to, and then there's this page that says, hey, do you want to integrate Slack? If so, give me your authentication token for doing Slack integration. Slack is an instant messaging tool. Probably a lot of you are familiar with it. And there's another entry here that says, do you want to integrate sauce testing? Which sauce is Selenium testing as a service. If you wanted to integrate Selenium testing in your app, just enter your sauce credentials here, and we'll set that up for you. So you go and you enter your credentials, and the fact that that page is still loading means I'm not going to even try this. So you enter your credentials in there, and you hit deploy. And what it goes off and does is, instantiates the app, clones the Git repository for you, sets up in this case we're using the Travis CI build. So we're setting up a Travis build for you. And we're going to do all of the integration of the tools that you requested from, today it's a short list, but imagine this is a much longer list, and maybe there's lots of different choices on which one you want to use. So what this will do is it'll set up, actually I've got a view here of what the Travis, this is our own front end on CI, but what is set up here is a deployment pipeline for my app. So I've got the first phase on the left is a build. It's going to do an npm build of the app for me. It's going to then run Node and do a set of unit tests just locally within the build container. If that passes, so each of these phases, if one phase passes, it'll go on to the next. The third phase here is it's going to deploy that app into an instance of that app into the production world, but under a different name. So it'll be a test instance of the app running actually in Bluemix, in this case, in the production world. And then it's going to run this, I asked for Sauce Labs testing, so it's going to run the Selenium test suites that are in my app for me. And then finally it's going to deploy it to production environment if all goes well. And at each step of the way, it's going to do notifications in Slack, because I asked for Slack integration. So, and again, I ran this earlier today, and you can kind of see it's got these notifications: build stage number 2, deploy to dev, deploy to production. So it's already done the integration between CI and Slack to do those kind of notifications. So the idea here, actually, so how did it do this? So, and again, let's see if the network's going to cooperate here. The magic to make this happen, it's now actually faster. So what I have, and you're not going to actually be able to read this because it's really small. I have this toolchain YML file, which is a configuration file that's specifying what kind of development tools to use for this app, and it's embedded directly in my source repository. So the reason that the tools know how to do that setup for you is the first time the CI engine cloned the repository, it goes, oh, there's a toolchain file. It's telling me it's got some tools that it wants to configure, and it's got the metadata in here to tell it how to configure those tools, and it's got these parameterized commands in here, parameterized entries for things like usernames and auth tokens that are things you obviously couldn't be storing in your repository. So wherever it saw one of those, that's where it came up with that box and prompted and asked you to provide those values. So basically, this declarative description of your development tool chain was used to drive both prompting for the necessary information to do the integrations, and then driving the work of actually wiring all those things together and making them work together. So yeah, so here I've got build, and it says Sauce Labs, and then messaging plug in the Slack capability. So that's where it's driving all those smarts. Any questions about that so far? Just of how that works? Stunned silence. Completely
So when you
confused.
say you deploy to, you click the button deploy to
Mhm.
deploy to Bluemix.
Mhm.
What is the requirement there? Do you need to have
Well,
what kind of infrastructure do you?
Well, so it's working by analyzing what's in that Git repository from that point. So if you just give it a Git repository that has that doesn't have that toolchain file, then it basically will try to guess. So if it finds a node manifest, it'll say, oh, it must be a node app, and I'll create a really simple pipeline that just does a node build and deployment. And it does, if it finds a POM file, it sets up a Maven build and does deployment of a WAR file to Bluemix. So it does, introspection on and set automatic setup as much as it can. And if there is that toolchain file there, then it knows a lot more about, oh, here's some Selenium tests it wants to hook in, and here's some other things. So it's an entirely optional bit of extra information that helps it do the setup for you more quickly.
But I meant on the other end.
Yeah.
So what do you need in terms of where you deploy to?
Well, in this case, what that particular toolchain is set up to do is deploying it to the Bluemix runtime environment. So, it presupposes I have an account on Bluemix. The first step it would have asked me to do when I clicked on that button is log in to Bluemix, and if I'm not already registered there, then it's going to ask me to log in. So it's sort of required, it's not like all of this happens for free, but it'll guide you through that setup. If you don't have a Bluemix account, the first thing it'll do is say register, you go through that, then you'll continue on with the setup. So it kind of tries to give a guided flow through everything you need to do to get set up to run. So, is there another question? Or?
Yeah, you mentioned Travis, but actually what you showed was the Bluemix continuous delivery service.
Yeah, so actually that's just a pretty face on Travis. It's a UI that our designers thought that the CI engines out there all had ugly, really poor user interfaces. So there is a nice front end that's tiles. It's supposed to be mobile friendly, so it's all tiles, and that's just a front end GUI on the build system. We actually switched. It used to be Jenkins as of a few weeks ago, and we switched to Travis, but the UI is still the same. So it's using Travis as the execution engine under the covers, but it's got a kind of a pretty face on it just to make a nicer experience. So you get really varied opinions. Like experienced developers who've used these tools before, love the power and complexity of Jenkins or Travis UIs, but new users get really overwhelmed by it. So this is just kind of a nice front end that makes it's easy to visualize and easy to use. It even does things like if you have multiple build stages, you can. I'm not going to. I won't bother. It lets you drag and drop a build from one stage to the other if you want. So if you want to say, I just want to take this from my test environment and drop it straight into production, you can actually do it from the UI. So it's just kind of a pretty face on it. Where was I? Okay, I got some backup slides if I needed it. So how am I doing for time? Getting close to the end, right? 5 minutes. Okay. I just want to show you a couple of the tools that we're using on our team that kind of illustrate the point about the fact that these tools have to be running out there and not running locally, and why we have these integration pains. So one really great one is New Relic, which is a monitoring tool. It does lots of different things, but one of the things that it's really neat for is doing performance analysis. And this is the kind of thing that you used to be able to do locally, right? You could fire up a profiler locally, if you open your browser dev tools, you can see the performance of all the requests. But that is a very narrow view onto your runtime. So if you're sitting in on your corporate LAN with a super high-speed connection, you fire up your app, you open your debug console in Chrome, and you look at the performance, you might come to a totally different conclusion than the real-world user out there. So one thing New Relic does is it simulates a real-world user out in the world in different locations. In this case, I have a monitor set up on Portland, Oregon, and Tokyo, Japan, where I can see how a user in Tokyo and Portland experiences the app, the load time. And I can see that over time, which is extremely valuable dimension. So, if I'd done my performance analysis on Friday, I might have come to the conclusion that image loading was my big bottleneck. And if I'd done my analysis on Saturday or Sunday, I might have come to the conclusion that it was the raw text loading time that was the real bottleneck that I need. And I might have gone off and done a lot of work to optimize that, and then realized that was a blip. And in the long-term trend, the biggest cost is something else entirely. So, this tool only is successful because it's connected straight to your runtime. It's basically using your runtime app as an end user would, and doing it over time continuously and giving you that complete picture of how your app's behaving is something you just never could do with a local tool for this kind of application. Another tool that has become very popular for actually all kinds of developers, but in particular for people doing continuous delivery, is Slack, and there's others like HipChat that are similar. And essentially these are, as far as messaging technology, this is not anything rocket science. This is essentially IRC on steroids with a pretty face. So it's got really nice apps, really nice mobile apps. But the real killer feature of these messaging systems is their integrations. So I've got just one of the screens of the Slack integration configuration page where it shows, there's like over 100 different kinds of tools that Slack can integrate with. So it lets those tools connect, to your team's chat room and give you information, and you can have, a bot that's even driving some of those tools. You can have some, you can use Slack as the interface to connect, integrate and connect to a lot of these different tools. And I looked at our Slack team channel, which has it's like something like 600 users in it, but has over 300 tools integrated in it. So all the different development teams have found 300 different tools to connect into Slack that help them get their job done. Whether it's monitoring, we use PagerDuty that notifies when the site's down. We use, New Relic monitoring alerts for unusual load times. We use, a lot of people have their builds set up to integrate there. So there's all these different kind of tools that are integrated. I'm getting a bit low on time. What else have I got? So log monitoring is another area that's really big, and there's actually two tools that our team uses that are really great that I'd recommend checking out if you haven't used them already. The first one on the left is called Splunk, which is a commercial tool. It's not open source, but it has actually the free version of Splunk actually is pretty good. It lets you do quite a lot for no cost. It's called Splunk Lite. And what it lets you do is it's essentially a nice front end on the Lucene database that lets you do searches. And one of the things I've got here is showing me the average response time over time from my HTTP access logs. So it really helps. You have these megs of logs being, piling up, and digging through them with grep and with a text editor is just not a good way to get value out of them. And when you feed your logs into tools like this, they really come alive. Like you really discover what's going on with your application. And the one on the right is using Elk, which is an open source log aggregation and monitoring stack. It stands for Elasticsearch, Logstack, and Kibana. And again, one of the things, in the past what we do is the site's not working well, we'd go and try it, and we'd say, oh, it works for me, I'm done, right? But if I look at my logs, I can actually see, no, there was a period, at 2 a.m. where for 10 minutes, this particular operation was failing for everyone. So clearly there's a bug there, and just trying to reproduce it myself as a developer, I can't see that. But when I dig into the logs and when I have the tools to do the analytics on the logs, I can discover, the truth of what's going on. Anyway, I think I'm just about out of time. So I had a couple of other tools, but I just wanted to just mention a couple things. So there's this contest at the IBM booth. If you want to win a GoPro camera, all you have to do is play a video game. So it's not very demanding. So check that out if you're interested. And I guess I'm just about out of time, but if any other quick questions from anyone? Yep.